Hey to you, welcome back. Today we're starting in a high-level system design of a chat application. I'll create multiple videos for that. So in this video, I will only talk the high level of the application, and after that, maybe we'll get deep dive on each component, and even maybe we could talk about the database schema and stuff like that. So maybe we'll make like 10 to 12 videos and focus on each subject by its own. I guess by that we will learn. We will learn the chat application in the best way possible. I'm just trying this one in the first time, so if it works, it works. If it didn't work, yeah, we go as we do before. So this system, it's inspired by the blog Algo Masters. They created a blog talks about how to design a system design of a chat application. So the full video actually was taken from them. I will put them in the resources in the comment section below, in the description. Sorry. So feel free to check it. So we want to create a chat application that has done functional requirements, and capacity estimation. And I put these things first because I would say this is the most important step in your system design interview. You have to figure out the non-functional requirements, the functional requirements, and you have to make the capacity estimation. And you also have to do this collaboratively with your interviewee, with your interviewer. Sorry, not you are the interviewee. So basically, we have here non-functional requirements. So basically, we want scalability. We need to handle millions of users. We need our system to be highly available. We need our system to have extremely low latency, and we need to make our system as reliable as possible. In the functional requirements, we want to support one-to-one real-time messaging between users. Also, we want to show online, offline status and last seen time of users. Also, we want to show message delivery status like sent, delivery, read, etc. We want to also allow users to share images, videos, and audio clips. We want to support group conversations with up to 100 members. We want to store and retrieve chat history and for each server. Also, we want send push notifications for new messages if the receiver is offline. The capacity estimation, the storage requirements for messages, we assuming each message is around 1 kilobyte. The daily storage, it will be about 5 terabyte if we have like 5 billion messages. And the annual storage, it will be like 1.8 petabytes. The bandwidth estimation for real communication. With 10 million users connected concurrently during peak times, the average bandwidth per connection, assuming an average of 10 kilobytes per connection, we could need about 100 gigabytes of bandwidth to support real-time messaging, a peak. So I highly recommend you to just pause the video here and just read all the requirements, the functional requirements and non-functional requirements, or go to the link that I will put in the description, because yeah, everything I am describing here, it's actually in the blog post. So let's start next. I need to have a pen. Okay, so we have our system here. This is the high level design of our chat application. We will go through each component here. The first, we have our users. So the users, these are clients, like people using the chat application on their phones. And we have the CDN. The CDN, we're using it to make it easier for the users to get static content like images and stuff like that. Basically, the content, the CDN will store the images and scripts and all the assets into the location closer to the user, so it will make the response time way more faster, because we need pretty low latency. Because of that, we did add a CDN. Next, we have a load balancer. The load balancer will distribute all the incoming web sockets requests, and we will talk about this in a bit. Web socket requests, connections marked as web sockets, as you can see here, from users to the available chats. We have here server A and server B, and there is a web socket connection. Why we have a web socket connection? Okay, so as easy as we can say it. A WebSocket connection, it's bi-directional communication. So when user 1 send a message to user 2, it will go through the load balancer, it will go through the system, it will go through everything, and the after the message is being served and saved, all of that things, it will be able to be sent back to the user. Because if you want to think about it like that, I have a system that I need the server to be able to send requests without the clients to asking it. So because we need a super low latency, we need to make near real time message delivery. So we can't handle polling. We can't work on polling. We need to have to work on WebSockets. If you want to know what all the difference is between WebSockets and polling, I highly recommend you to watch my previous videos that talks about polling and WebSockets. And I will also create a new other videos that talks about only WebSockets and polling in context of a chat application. So we're using WebSockets because it's a bi-directional communication. The next, we have the chat servers by itself. We have server A and server B. These are a real-time brains of the system. They maintain on WebSocket connection with users. They handle message routing, like if user A sends a message to user 2 or user 1, sorry, not user A. If user 1 sends a message to user 2, the server will find where user 2 is connected and sends the message to it instantly. They also interact with message queue, notification service, and user connection database. So we have the user connection next. So this one, it's a stores which server each user is currently connected to. For example, user 1 is connected to server B or server A. When a message comes in, this helps the system quickly locate where to deliver it. We have a group service here. The group service and the group DB, they manage group chat information. Example like group ID, group members, group metadata. Whenever a message is sent to a group, this service will figure out which users should receive it. And I will create another video that talks in details about how group messaging works. But yeah, today we're just only talking about high levels. Next, we have the message queue. So the message queue will act as a buffer between chat servers and the storage layer. It's used for reliability because we need our system to be reliable. If storage goes down, messages won't be lost at all. Also, it's quite scalable because the chat servers don't wait at all. They offload messages quickly to the queue. We can use Kafka for that, or RabbitMQ, or even Amazon SCQS. We have next the message storage service. So the message storage service, these messages from the message queue and saves them permanently into the database. They takes the messages from the message queue and save them permanently in the database. They can apply business logic like checking for spam, maybe storing metadata like timestamp, delivery status, etc. And next we have the message DB. This one stores the chat history, like could be shorted horizontal to scale. Yeah, notice that there are multiple DBs. Yeah, we will need to have multiple DBs, and I will talk about the storage in a bit, but just be patient. Okay, next we have the notification. Sorry, we have notification service. It sends push notifications when a user is offline, integrates with mobile push services like Firebase or EPNs, which is for Apple. It's basically example like it will be like, hey, new message from John or from Muhammad or whatever it will be. So we have the blob storage, we have the blob storage, the CDNs, and I guess we have the media storage store. Where is the media storage store? Yeah, I guess also this. So so this one, media service. Sorry, media service. I didn't talk about media service. So the media service will handles uploading and downloading files, images, videos, voice notes, all that things. It will store the files in a blob storage like Amazon S3 or cloud or Google Cloud Storage. It delivers files efficiently using CDN, which is a content delivery network, so users around the world can download media quite faster. Okay, so let's try and understand how does it work. So let's say that user one will connect via WebSockets with the load balancer, and the load balancer will connect it to a chat server A. For example, the user one will send a message to user two. So the chat server A, which handles all the related things to user one, will check user two's location. We'll check the user two's location using the user connection cache service, and after that it will deliver the message in real time if the user is online. The chat server A will write the message to the message queue. Okay, it will write the message to the message queue, and after that the message storage service reads from the message queue and stores the message in the message database. If user 2 is offline, the notification service will trigger a push notification. If media is shared in this message, like there is like an audio or image or whatever it will be uploaded to the media service, which will upload it to the blob storage. Also, it will be uploaded with the CDN as well, so it will be for faster retriever. Why? Okay, so if you want to talk about the DBs as well in details, we have here the message DB. The purpose of this one, it stores all chat messages permanently, both one-on-one and group messages. The requirements of this one, I guess it should be high write throughput, like millions of messages might come in every time. It should be efficient querying for loading chat history, pagination like time-based filters, things like that. It needs to be scalable, so it needs to scale horizontally. I guess we can use like NoSQL, like Cassandra or DynamoDB, greater for write-heavy workloads. We can use a relational as well, good for consistency, but I would prefer using NoSQL database for this one. In terms of the group DB, we stores group related metadata like group name, number, members, admins, etc. Group creations, modifications, and timestamp. I guess we can be enough with the relational database with this one. Yeah, it will be best because you need consistency when updating group members or settings. Next, we have the blob storage. I guess we can store images, voice notes, and videos, etc. We can use Amazon S3 or Google Cloud Storage or even Azure blob storage. Papa, do we have anything else? If you want to talk about the user connection cache, it's a temporary stores real-time data about user connections. We can use Redis. Why Redis? Because Redis is quite fast. It's in-memory store. It supports automatic expiration (TTL) if users disconnect unexpectedly. It works perfectly for real-time systems where data doesn't need to be persisted at all. I guess that's it for this video. I might create some. What am I create? Yeah, I will create some more videos in the future. Maybe we talk in details about why we're using the WebSockets instead of using polling. Maybe we talk about details about the database schema, because I didn't talk about the database schema at all. So I guess it would be a good idea to talk about database schema. Maybe we talk about the group, how the message works in groups, and yeah. I don't know how many videos we put, but like I will estimate it maybe like 6 or 7 more videos. So yeah, that's it for this video, and see you in the future.